Hi there, welcome to your quant lesson of the day. In this video today, I'm going to save you from a trap that a lot of GMAT test takers fall into. There is this history that we have with linear equations in two variables. The moment we see a single equation with two variables, we just reject it as something we can get nothing from. But today I'm going to show you how you can make powerful inferences from these equations, just a single equation in two variables, and how that can be the difference between you getting and not getting a 700 level question correct. Let's get started with a simple exercise. Right, here you go. This is some given information. Just read this very carefully. You have two unknowns x and y, and I know these are positive integers. Positive integers would mean they can be anything from this list 1, 2, 3, 4 going on forever. And then there is this equation that relates the two variables. 6 times x plus 5 is equal to 7y. So it's a single equation in two unknowns, and these unknowns I have something about the kind of numbers that these are. Now my first question to you is, can you find the exact values of these two variables? Can you give me exact value of x and y? Pause the video, think about this first exercise first. Alright, I hope you try. Well, the answer to this is no. You cannot find the exact values of these two variables. I'll just give you one example. Say x is 2 and y is 6. Just plug it in and you can see that it works. Similarly, there's another one, 9 and 12, x9 and y12. Even this one works. So now also there are actually going to be infinite possible values of x and y. You cannot get exact values. Now this is despite the constraint that these are positive integers. If that was also not there, then obviously we are already habituated with rejecting such situations when you have a single equation in two variables. But yes, we can't find exact values. Does that mean we stop right here every time we get something like this in a question? No, if you stop, then that's exactly how you're going to get your question wrong. Take this a step further and try to infer all you can about these. So here in the same set of information, the same given information, I want to see what I can infer about x and what about y. Let's just focus on one of these at a time. So let me just focus on inferring about x first. So let's have y out of the frame. Now, look at this equation and focus on the part of the equation that does not have x in it. Since I'm trying to infer about x, I'll take the part that does not have x in it. Now, there's nothing I want you to memorize here. It's just a process that you will see forming up. Okay, so start with 7y. Now, what can you say when you look at 7y? 7y very visibly is a multiple of 7. I can see the 7 here, right? So this is a multiple of 7. Now you know 7y is equal to 6 times x plus 5. Those two things are given to be equal. So if 7y is a multiple of 7, then 6 times x plus 5. This is also a multiple of 7, right? Now, one step done, we've at least come to x. X was the one we were interested in. So this way we've reached x. Now 6 and x plus 5, it's a product of two numbers which is divisible by 7. Think about how a product can be divisible by 7. Either both of those numbers together contribute to create a 7, or just one of them does. For example, I have 2 times 3. Then 2 times 3, the product is divisible by 6. Not individually, 2 is not divisible by 6, 3 is also not divisible by 6, but both of them together contribute and then they become divisible by 6. In this case though, 6 doesn't share any common factor with 7. 6 is not even contributing towards 7. The reason that this product still is a multiple of 7 is that x plus 5 is a multiple of 7. Now you have some information about this x, which till now was nothing but a positive integer. Now instead of having infinite possible values for x, you have a finite set. Let me write that here. One second. Let's just go and write some possibilities of x plus 5. So since I know x plus 5 is going to be a multiple of 7, and x itself was positive, so x plus 7 is also positive, the values it can take now are 7, 14, 21, 28. You can go on forever. And the x values also that you will get will come from here only. Now you can't just have random x's, right? So x's that will come from here will be these, and again you can go on forever. So from the set of all positive integers where you were allowed to have 1, 2, 3, 4 forever, now you have a much more restricted set. This inference that we made about x plus 5 being a multiple of 7 has greatly reduced the set of possibilities for x, and you will see how this very valuable inference helps you when you're trying to solve questions. Before I move on and show you proof of that, let's also see how the same thing would be done for y. So let's get in here about y, and again follow the same process. Okay, so what am I trying to do? Remember, you start with the side that does not have y in it. So which one is it this time? It's the left hand side. So I'll just take this much and then we'll zoom into this part. So 6 times x plus 5 visibly is a multiple of 6. I can see the 6 here, right? Now, because 6 times x plus 5 is equal to 7y, I can say the same thing for 7y. That 7y is a multiple of 6. Again, it's a product of two numbers, 7 and y. But 7 does not share anything in common with 6, and therefore the reason this thing is still a multiple is that y is a multiple of 6. And there you go. This is your second inference. This one is about y. So instead of having all possible positive integers as values for y, now you only have 6 and 12 and 18 and so on. Yet again, it's a much restricted set compared with what you started with. So with these inferences, let me just first put the tags for you. 1 second. All right, so these are the two inferences we made, one about x and one about y. Now it's time for me to challenge you on an official question. So try your hand at this official question 700 level, pause the video, try this and see how the inference that I taught you will help you here. Alright, I hope you tried. Now here is the complete solution to this. This is right now just an image, but don't worry, you don't have to just understand everything from an image. I am going to give you the link for this complete video solution. But just focus on the part that we really did. You see, this is the exact equation that we started with in our exercise, and the inference that we made then was about x plus 5 being a multiple of 7. We in fact also listed down these values. Now when you actually use these into the statements, the working there becomes really simple. See how? When I have in statement 1 that x is less than 9 point something, I don't have to think about 1, 2, 3, 4, everything till 9, which are all of the possible positive integers. Instead, I am only going to see what is in my list. And in my list, there are only 2 such integers that are less than 9 point something, and I'm directly here at 2 values instead of 9 values that I would have gotten. Similarly, from statement 2, when you come to this part, x less than 5, you really have just one value, just 2. And this gives you x, making this statement sufficient. You have just solved the question, you know what we wanted. Now here, this is the power of making simple inferences. Inferences that as you go, you make them, and then the rest of your solution becomes super simple. Now here are your takeaways from all of this exercise. Now, whenever from now on you have an equation that has variables on both sides, for example, the one that we had, you will never just give up. You will always think of how you can make inferences about the variables involved and see how those then will help you. Every time that you make these inferences, it will put constraints on your variables. It will not just be all of the possibilities that you started with. This restricted set will help you get closer to the solution. It's a critical skill to have, especially in data sufficiency questions, just as you saw in this one. Now, before I let you go, here is a small practice exercise for you. I have some given information, 2 positive integers a and b. This is an equation that relates the two. You have to make inferences about both of these variables, about a and about b. Now you will put your answers in the comments. I will read each of those comments and evaluate your answers. How will you give your answers? You will just write down your answer as point number 1 and point number 2. one for this one and one for this one. For the first one, you will just say A is and then whatever your inference is. Similarly, B is and whatever your inference is. Just stay here in this format, which will make evaluation really easy and more effective. Stay tuned for more such videos. Subscribe to the channel because we are going to get a lot of these videos. If you liked this one, hit the like button. I'll see you next time. Happy learning.